If you are trying to become a data scientist in 2026, stay with me for the next few minutes because I want to walk you through the only roadmap that you'll ever need. Being a data scientist is one of the most rewarding careers. You're sitting at the center of it all, where technology, big decisions, and real insights collide. That kind of position feels almost superhuman, and it gives you a role that every data-driven company, which is everything nowadays, genuinely can't do without. You get to be a true scientist, running experiments, playing with machine learning and statistics, and digging for the kind of insights that reveal what's really going on behind everyday workflows. With the prolific advent of LLMs, some are claiming that coding and software engineering are dying, that the field isn't as secure as it once was. That's a full-blown topic for another day, but I would argue that the field is just changing. And those that are most successful are leveraging, not shunning, these new tools. And they are thriving, and the demand is absolutely still here. Don't just take my word for it, though. The US Bureau of Labor Statistics projects a 35% growth for data scientists through 2034, with about 23,400 annual openings, outpacing average occupations. Entry-level saturation persists, but AI-skilled roles in particular, 60% of postings requiring AI, especially LLMs, see 5 to 12% higher median salaries. The World Economics Forum 2025 ranks data roles among the top 15 fastest growing globally. My name is Connor, and I am a data scientist in a US telco, and I'm fascinated by how this field is changing. I also spend a lot of time speaking with smart engineers, professionals, and students who want to move into data science and be part of the excitement. The obvious question I always get is, how do I start? What should I learn next? This right here is where roadmaps can become helpful. Yet, they're only helpful if the order actually makes sense, so you have a strong foundation, and they need to be designed so that anyone can jump in based on their experience level. Today, I'm going to be showing you one of the best roadmaps I've seen for 2026. It's adapted from a rigorous program Interview Kickstart runs, and also show you the alternative way you can modify it if you want to self-study. Let's walk through it step by step and see how someone gradually goes from learning the foundations to operating as a data scientist in a production environment. First, take a look at a high level before diving a little bit deeper. We begin with Python programming, move into database and SQL, then into mathematics and data analysis, followed by machine learning, deep learning, big data analysis, data visualization, storytelling. And finally, to end it off, we go to capstone projects and interview preparation. The key here is that every previous phase is setting the foundation for the next one. Knowing the technical side of machine learning is important, but won't click very well without the ability to apply that knowledge in the programming languages that you are learning. This full idea follows Bloom's pyramid of learning. The pyramid essentially shows the level of thinking required for a given task. Now, as you progress up the pyramid for a given topic, you start to understand it much deeper. Pure memorization and understanding is at the bottom of the pyramid, indicating that purely studying material and trying to memorize just makes it very hard to retain. At the top is using that information to actually build something that didn't exist before. And this is what I love most about the Interview Kickstart program. The emphasis on actually building things through projects and solving real data sets, all while learning alongside a cohort of other engineers guided by instructors who know what they're doing, and they have the experience to say, this does work and this does not. Let's dive in a little bit deeper to each of the aspects. We start with foundational programming. Every programming language has its uses, and I would highly, highly recommend that you branch out and learn multiple. For example, Julia, R, C++, or Rust. Knowing when to use each language is a skill in itself, and you can hear about that from me in a future video. By far, though, blowing everything out of the water in the field right now is Python. This is beneficial to new learners, actually, because Python is one of the easier languages to learn and is much more forgiving. At this stage, we really just want to get a strong foundation in Python. Things like the core Python syntax, data structures, and object-oriented programming, those are key anywhere and would transfer across any domain. But working with key data science libraries or packages such as NumPy, Pandas, Polars, scikit-learn, Streamlit, Matplotlib, there's a ton of them. That is going to be a key as you move forward in this career. In conjunction, you also learn SQL for data analysis, starting with your database fundamentals and moving into more advanced querying. While a lot of starter projects and college classes have you working off of CSV files or Excel spreadsheets, in production big data environments, these file formats just don't work. SQL is made for querying large relational databases, and there is no data science, no machine learning, no AI, no insights without data. Now that we have the foundations in place, and mind you, as I said, these foundations will help you in any coding role, not just data science, the curriculum shifts into statistics and probability, covering topics like conditional probability, probability distributions, statistical measures and frequentist versus Bayesian thinking, and hypothesis testing. Each of these form different pathways of thinking, if you will, that we can apply to problems, and allow us to determine if the insights that we are finding are real or are they just noise in the data. From there, the program moves into data analysis. This includes exploratory data analysis, feature engineering, visualization, and even AI-assisted analysis workflows, where generative AI tools are helping accelerate insight generation, not replace it. This is often where most of data scientists' time is actually spent. Getting clean data that tells a strong story is really hard. Without these critical steps, the machine learning or AI models just don't work very well. The machine learning core includes regression versus classification algorithms, ensemble techniques like random forest and XGBoost, how to evaluate the performance of a model, how to tune the model to be even better through hyperparameter tuning, and a bunch more methodologies like clustering, dimensionality reduction, and time series forecasting. Now, all of these topics are common interview questions that you will hit. Each one of those by itself is a deep topic, so be on the lookout for when I dive deeper into those in a future video. As I mentioned before though, just memorizing technical details of each of these really is not enough. You need to be able to apply that knowledge and build with it constantly. That is why Interview Kickstart learners complete mini projects as they are learning, like building a churn prediction model or a customer segmentation. Each of these cement the ideas and allows you to explore what a typical workflow of getting a model to actually run looks like. After the machine learning foundation, the program introduces specialization tracks, where learners can focus on different levels of AI, such as legacy AI, classical AI, neural AI, generative AI, and agentic AI. Or, if you would like, to transition into pushing these models into production environments with MLOps, or perhaps you're looking into decision science. Everything here culminates in a capstone projects, where learners define real business problems, build a solution end-to-end, really own it, and present the results. Once you've done that, at that point, really the last thing to start doing is prepping for your interviews. And the program helps ensure that you have a strong understanding across the board. Interviewing is a skill, just like anything else, and the best way to learn it is by doing. Now, these last two I've said are unfortunately a little bit harder to be self-studied easily. You can cramp in and just try and learn all the technical aspects and memorize, but as we talked about, it just doesn't work very well. The reason that this course is so popular is because it's so hands-on and builder-friendly. Self-study is a good place to start, and I'm not saying to not do that. You absolutely should, and use it to augment your learning, but learning from highly skilled mentors and with a group of like-minded, ambitious engineers just increases your absorption of the content and your learning, and overall increases your chances of succeeding. That is it for the roadmap today. I hope this has been a helpful high-level overview. I put a free webinar link down below, so you can go meet the team, dive deeper if you would like, and see if it's a good fit for you. Let me know if you'd like me to cover next, and until then, see ya.